First of all, we should always start or at least end at the MDN documentation for this kind of like a command. So I have opened Promise.all, all settled, and race on MDN. We're going to take a brief look at the description. And then I found these really nice diagrams from a blog post that I think give a really good visual representation of how these methods really behave and how they differ. All of these methods have to do with handling multiple promises. So they're all three of them are about getting two or more promises and handle the way that they kind of like race together or run concurrently, and then at some point finish, and we want to do something with the result of these promises. So you would go into Promise.all, all settled, or a Promise.race if you want to deal with two or more promises. Now, I'm going to start with the Promise.all, and let me explain a little bit this diagram. So in here, we have like this horizontal kind of like scale is the time. So we start from 0 seconds. And then we have these three promises that take some time to complete. So we have this first pink prom1 promise that takes roughly 3 seconds to settle, to finish and complete successfully by providing some kind of a result. You can think of this as a promise like fetch, where you try to fetch some resource from a server, and then after 3 seconds you get back the result. At the same time, we have another promise prom2, which takes around 5 seconds to execute and complete. And we also have another promise prom3, which takes roughly 4 seconds. So basically, the idea behind Promise.all is to take all these promises, all these three promises, have them run concurrently. So all of them start, as you can see, at the beginning at 0 seconds. They start concurrently running, and then they finish depending on how much time they need to get the results. And the Promise.all allows you to make sure that all of them finish and successfully complete. They all resolve. And then once all of them have been resolved, we can take the result of these three promises, these three values, and then do something with them. In this case, it's important that the Promise.all will successfully come to a resolution once all of the promises, whether it's 2, 3, or 3,000, have been successfully resolved. So you can see this green check mark, which means all of them take some time, but at the end, all three of them successfully return back a result. And the idea is I'm going to be using Promise.resolve, which is kind of like an easy way to quickly come up with a promise, and that promise will evaluate to a value. This is value 42, or you can pass whatever value you want here. It's just an easy, cheap way to launch a promise that will successfully resolve to some kind of value. So I'm going to use Promise resolve to actually bundle three promises, just like in this diagram together, so we can see Promise.all. And I'm going to say Promise.all, and in here, basically Promise.all accepts one argument, which is going to be an array. And inside this array, you're going to bundle all of your promises. 2 or more promises will have to be placed in here. Usually you have, like you store the promises in a variable, or you have some kind of function that starts a promise. In this case, I'm just going to put the promise resolve in here, just for simplicity. So I'm going to add 3 promises that will resolve, all 3 of them, and they will resolve instantly. Okay, I don't want to spend too much time doing some timeouts here to have them take up some time. And Now, this is what the Promise.all does. It gets an array, a list of promises, and it makes them, it launches them, it starts them, it fires them up all at the same time, just like in this diagram. And when all three of them have been successfully resolved, we will get back an array which will have exactly the same length as the initial array. So we're starting three promises. We are expecting an array of three values. If these were like six promises, the result that you will see in a bit will have to be an array of six values. Okay, every promise will have to put the value, the result, the value that it returns inside the returning array. We will see that in a moment. Before doing anything, I'm just going to run the command, and you will see that it immediately gets into fulfilled state because all of them instantly resolve. So what we get back is another promise. The result of Promise.all is another promise that is in fulfilled state, and it has a, I can open up here and see the promise result, which is an array of three elements, of three values, first, second, and third. So this promise resulted in another fulfilled promise that has this array. Once I get a promise, I have like quite a few ways to handle the result. The most simple one is to just create a uh, uh, then method, and then inside there I will pass an anonymous arrow function in here, pass a function that will handle the result, the successful result, the successful resolution of all three promises. So take all this, run them, and then you'll get the result here. The value will be the first parameter of this function here. So I'm going to name it values. Remember that Promise.all, Promise.all.settled, and Promise.race, they all return a value that is an array. We get an array of promises, we always get an array of values. And in here, I'm going to just console log the values, which means I also have access now, direct access through my code. This was just some debugging, tool, but in my code, I will have to use them to handle the resulting values, which is an array. And then, of course, I can say, give me like the first value, or give me like the second value, or do something like fancy, like concatenate the values together. And, I don't, maybe these are numbers, and that's values 2. And you just get the result of three promises, and then you concatenate them. Or if these were some numbers, so you picked some numbers from three different databases or three different tables, and then you want to sum them up, probably you would sum these three values together. But you have these three promises working independently, concurrently, so things move faster. So this is how we work with Promise.all. And in here, in this diagram, you will see that the Promise.all resolves only if all of the promises successfully resolve. If one of them rejects, if there's an error in one of these promises, we're going to be seeing another case. So in this diagram, you will see I have the same three promises, but for some reason, Promise.2, Prom2 rejects. No, sorry, the Promise.3 rejects. So they all start concurrently. Promise.1 successfully resolves. Promise.2, it keeps going. It's trying to fetch some data and takes quite a while. But Promise.3, after 4 seconds, comes back as rejected. There's something happening during this promise process, and then it rejects here. In this case, Promise.all will stop here. It will disregard what's currently running in the background, the Promise.2. It says one of my promises rejected at this point, around 4 seconds. I'm going to stop here, and I'm going to reject So Promise.all means I want all of them to be resolved and get all of their values. If a single one rejects, I'm going to stop there. It's either perfect or I'm going to reject. And this is where you're going to be using Promise.all when you want all of your promises. It's really crucial for you to have all the promises successfully resolved. You really need this data to combine it or use it in some way. You cannot do something useful if one or more of the promises reject. So in this case, if I reject, let's say the second, I'm going to use the static method promise.reject. In this case, the promise.all will break. Let me just console log the values here, and you will see that we will not see the value. So the second promise rejected, as you can see here, it's kind of like broke the whole Promise.all procedure, and Promise.all stopped right there, rejected with the value of the first promise that got rejected, and we get that value. And as you can see, we cannot see the console log value here because this promise rejected, so we need a cut to cut the rejected value, which means if I also want to handle the case where one or more promises, or at least one promise, uh, reject, I'll need to, let me put this here so I can distinguish between the values and the errors. So in this case, we'll start this promise.all, reject, the second promise will reject, will fail, and then promise.all will skip the then, because that is the method that handles the successful result of all promises. But since one of them rejected, we will go into the cuts and we will get the error of that particular first rejected promise. So in this case, it makes sense to put singular here. It's a singular error, the first promise that rejected. So let me clear and let's run this code. So you see the error contains the promise that rejected, the value of the promise that rejected. Now, in real life, of course, you will not see something as simple as a string. Probably you'll see an error object with some more information, maybe some stack trace or some other code. But in this case, promise in here in the diagram, it's a promise 3 that rejects. In our case, it's the second one that kind of like stops the whole process. And we have to deal with the error and do something. So you will use Promise.all when you have two or more promises that you want all of them to run concurrently in parallel, do their work, and then you either get a successful resolution of all the promises, or you get the error that you get back from the first promise that got rejected. A case where you want to use Promise.all is when you go out and you fed some data, or you do something like two or more promises, go out there and run some asynchronous operation, and you want to get back the data from all these promises, and based on this, on all of these values, you want like to do something. So let's say I have like 3 tables, one for my, let's say, premium accounts, one for my standard accounts, and one for my extra premium accounts, and I want to see how many users I have in all these, let's say, tables. So I spawn like 3 promises. One of them gets all my users, the standard users, another one gets the premium users, another one the super premium users. And when I get back, what I get back is 3 values: 1,000 standard users, 500 premium users, 20 super premium users. So I get back the 3 successful results. I sum them up and I see the total number of users that I have on my service or my platform. This is a case where you want to use Promise.all. If one of these promises fails, you won't be able to get the overview of or the total number of users. So in that case, it doesn't make sense to do something with like 2 or one of the values. You want the total. So when a promise rejects, you will show something to the user or maybe retry, because there's no use in doing something with half the data. So this is a case where we will be using Promise.all. I'm going to be sharing these really nice diagrams later on to keep them as a reference. Now let's go on to settle Promise.all settled. And I'm going to be using the same example here. I'm just going to switch to all settled. So the idea behind all settled is run two or more promises concurrently, let them out, do their work, and then when all of them like finish what they're about to do, not only successfully but also unsuccessfully, even if one or more of them get rejected, you want to bundle all these results, both successful and unsuccessful results, and then your promise all settled method will eventually resolve. It will not reject, it will just get all the values, both successful and unsuccessful, and then successfully resolve, which means you just have to use then, and then you will see all the values here. Now I will just check the three successful results first to see what we get. So I get values, an array of three objects. Now this is a bit different from Promise.all. In Promise.all, what you actually get is the result value from the promises. So just the value. In the case of all settled, you don't get just the value. The static method puts the value inside an object, and especially specifically in a property called value, and then it automatically injects another property which is called status, and in this status it's going to be the status of the promise, which in this case all of them have fulfilled because they all resolved. So if you want to get all the values and you want to do something with the values, you have to check maybe conditionally about the status. So if I want to get the first value, I'm going to need not just the value, but also the status to see whether it's fulfilled or, as we will see in a moment, a different value. So the value is picked from this object through the dot value property, and the status gives you some idea of whether this was successful or unsuccessful. You will see that this is not a really good, safe way to do this, because if the promise rejects, you will see that the object is slightly different, has a slightly different structure. But let's see just the successful. So we have all the values, once again, the array, and from the first value, we get into the array, we pick the first element, which is an object, we pick its value, which is first, and then we pick the status, which is fulfilled. Also, I can get like the last elements value and status, which is of course going to be third promise and fulfilled. And the order that this happens is in exactly the same way that you define the promises. So just like in Promise.all, in Promise.all settle, you have all the promises ordered, strictly ordered, as like the first, the second, the third promise, and the values, the values array will contain the results of these promises in exactly the same order. In the first array index, there will be the value or the result of the first promise. In the second index 1, you will see the result of the second promise, and so forth. So the order of the values array that you get both in Promise.all and all settled is strictly reflects the array that you pass in as an input, the promises input. Now let's see what happens in the case where one of these rejects. And in here, I'm going to comment this out for now. Now, if I were to use all, remember, these will stop exactly at the first promise that rejects, and we'll have to use a catch here to catch that second or that, let's say, first rejected promise. So I need a catch here to catch the case where one of these promises rejects. In the case of Promise.all.settled, I don't need to do that because I will always get into the resolved the state, which means I can just use then, but I will get a different value in this case. So now the Promise.all.settled waited for all of them to fulfill or get rejected. So it waits for all of them to finish, no matter whether they will successfully or unsuccessfully complete their work. And you will see that now there's a different object in the second case. In the case of promises that reject, the status will be rejected, a string with lowercase rejected, and there's no value. Okay, so this one, I mentioned this is not safe because in this case, if I try to pick the value property of the second array element, I will get an error because there's no value. So you get the status, you first check the status, whether it's fulfilled or rejected, and then depending on the status, you should either pick the value for successful fulfilled promises or a reason, which means that, let me just pick the first value. Usually you loop over the values array and you do something with all the values, but I will say, let's say first value, or let's say second value. Let me pick the second, and then I will check whether that second value status is fulfilled. Now, if we're in the fulfilled status, I can use the value property. Let's return just here. But if we don't get status fulfilled, it means the status is rejected. Then I will say second value reason, because that's the rejected, let's say, value. That's where the rejected value gets placed. So in this case, I will get, let me just put a number here to see which console log is going to be logged. So in this case, the second promise will be rejected. So I'm going to be here. I'm going to see the console log here. Second, if I'm going to use the okay, second value, but I will just pick the third now. So now we get into this if statement because the status is fulfilled and the value is third. So that's when you what you get with all settled. Let me go back to the all settled in MDN and see what kind of ideas or information we can get. So first of all, the status is either fulfilled or rejected. There's no third value. That's why I used just a simple if statement. And then you will get the information and the rest of the description for this method, which I highly recommend that you do. So we know that this is safe. We just have two values, either fulfilled or rejected, and we can safely assume that all of them completed their work and then do something with these results. Where should we use the Promise.all.settled in contrast to all? When you don't really want to stop the operation or the thing that you're doing if one of them gets rejected. So for example, let's see that we're building a dashboard and we have, let's say, some currencies. So we're throwing some promises to get some, let's say, or some stock prices. Okay, so we launch a promise to get the stock of Apple, another one to get the latest stock of Tesla, another one to get the latest stock of Microsoft, whatever. And we want to, as we get these values, to like display them on the screen in some cards. Now, it makes sense to run all of them concurrently so we get the results fast, but it doesn't make sense to stop the whole operation if one of these, let's say, stock prices fails for a reason. Let's say you're dealing with 10 or 20 stock prices. It makes sense to display, let's say, 19 or 18 of them Uh, and if one of them fails, you can either retry just on that one. So you show like most of the prices which have correctly resolved. And then for the couple of rejected promises, you either retry, you do another individual retry, or you can maybe display some kind of like an error icon on that particular card. So at least the user would see most of the stock prices, or maybe if this is some news site, they will see like most of the news or most of the news sections. And maybe if there's an error somewhere, you can deal with it in some way. So all settled means that you're not really strict about all the promises successfully resolved. Um, you can make use of the data that you get, and even one or more promises fail, you can live with that. So that's the case when we want to use promise all settled. And lastly, we are going to be seeing the race, the promise.race. So the same example here. Let me just delete this one. Now the diagram here shows you a slightly different view. So we have three promises that run concurrently. They start on, all of them start at the same point in time, 0 seconds in here. And then the race, as the name suggests, is like having these promises race against each other. Kind of like, and the faster the promise, one of these promises gets resolved, the quicker the promise.race will resolve and stop there. So in this case, after 3 seconds, the first promise gets resolved, and promise rate stops right there. It says, I got my first result from one of the promises. It doesn't care if it's promise one that finished first, or promise two, or promise three. It's just that one of the promises, one of the 200, 3, 2, 4, 10 promises, just got back with a result as quick as possible. So it's a race. The first one that completes the task successfully and resolves, promise.race will stop there, and will it will evaluate, and it will we will use the yen the then sorry the then once again to show the value. So this is value. So in this case, all of these are let me put for now, all of these are going to be instantly evaluated, so we probably always see the first one win the race. Okay, so in this case, you will see the first. Immediately when the first promise resolves, we use the then, and then we pick the value. If I were to run some kind of like timeout in here in these promises, or um, maybe some random interval, the first one that resolves, we would see its value in here. It doesn't matter whether it's the first or the third one. It's just the quickest one that wins the race. That's how promise race works. It makes sense to use this when you are, let's say, you want to get back one single value, one result about something, and you want to try different, let's say, routes. So maybe you have like 3 servers all over the world, and you have exactly the same data. So you say, okay, let's throw 3 promises and try to fetch data from these databases. All of them will give you the same value, like your total users. But because you don't know whether one database is going to be like slow or another one is going to be busy, you just say, go out there, find the quickest response from one of these 3 databases, give me back the result, and then stop the rest of the procedure, stop the other 2 promises. So that's one idea on how to use race. Or maybe you're, I don't know, like fetching some random content for a website, and you say, give me some video from this provider, some other video. And then the first one that comes back, you show it to the user, and then you forget about the rest. So race is, as the name suggests, racing to get the quickest result possible. But there are also other cases that has to do with computations. Maybe you run different computations on different like servers, and maybe get back the one that comes first. So there's all sorts of like use cases for the promise race. Now, what's really important for promise race is, as you can see here, this is the first promise that got back successfully with a result that resolved. Now, there's another case where one of these promises gets rejected. In this case, let me grab the code. Promise race works in exactly the same way, but instead of looking at the first promise that resolves, it also looks at the first fastest, let's say, promise that got rejected. So it's not only finding the quickest resolution, the quickest successful result, but also the quickest, let's say, error or rejection. So in this case, if I reject the first one, because I don't have any way to time this. So the first one is going to be rejecting first, probably. And you will see that if I run this, I don't get into the then. So promise.race will reject if one of the promises rejects, as quick as possible. And we need to use cats in order to handle this. In this case, it's unhandled. It's an uncaught rejection promise. So we don't see the value of console log anywhere, which means I have to also go back to the Promise.all kind of like a mode where I need both a then and a cats. Singular because we have one error, the one promise, and in here it's one value. So in this case, the first promise rejects, which means we're going to be handling this in the cats method. If I resolve this one and reject the other two, so the first one will resolve, the second one will reject, and the third one will also reject. Now, in this case, I believe first one will be the quickest one to come back with a result, a successful result. So Promise.race will disregard these two, and it will just get the quickest result it got back from race. So this is how you deal with Promise.race. It's similar to Promise.all in that you have to handle both cases, a successful and an unsuccessful, or then and cats, because even if one promise rejects, we will see something hitting this cat method. So this is the difference between these three methods. I would say spend some time to experiment with by using some more, let's say, advanced promises. So instead of promise resolve, you can replace this with some like fetch requests. So use some URL. In this case, this will be really something random. You will not know which of these fetch requests will finish first and which one is going to be successfully completing or rejecting. So you can try some APIs like JSON placeholder or other ones, and try to with a more like realistic scenario. And also think of scenarios, think of use cases for all three of them. Just sit down away from screen, away from keyboard, and try to think of how you would use these three methods in real life. I gave you like some really simple examples, but it makes sense to try and think hard about some more examples to really understand when you should be using this or one of these methods whenever a challenge comes in. So the Promise.any static method is static method just like all settled, resolve, reject. Static means that you have an object and you don't have to instantiate it with new keyword to run this method. You just put dot something, some static method, and you run it. It takes an iterable of promises and then as an input and returns a single promise. This return promise fulfills when any of the inputs promises fulfills with this first fulfillment value. So it's kind of like the race. So you pass in a lot of promises and you get back a fulfilled value. It rejects when all of the inputs reject, including when an empty iterable is passed. Let's see the demo here. This is just like the Promise.all settled race. You pass in an array of promises, and then you use then to do something with a single value. So you will see that they're also using value, which means that this promise will return a single value. In this example, we have, let me copy this and run it in the console, basically. Okay, I will put it here and we'll compare it with the description. So we have a promise that rejects. We have a promise that takes around 100 milliseconds to resolve, and then another one that takes 500 milliseconds. So we put them all in here. We'll let Promise.any take care of them, and then we'll get a value. Let's run this, and we get like the quickest promise, which is the one that finished after 100 milliseconds. So there's a kind of like set time out here, and based on the description, let's go back to the main description. So we took an iterable of promises as input. So this is the iterable is just a fancy way of saying an array. There are more iterable objects, of course, but an array is one of the iterable. And it returns a single promise. Okay, so here's the iterable, and then it returns a single promise. That's why we use then. And the return promise fulfills when any of the inputs promises fulfills. So in this case, the promise 2 was the quickest one to resolve, to fulfill. Okay, and this is why we got this fulfillment value. And it says it rejects when all of the input promises reject. So this is basically kind of like a little bit similar to Promise.all, but it says I'm not going to use like the all the values. Whenever one of these promises fulfills or resolves successfully, I will pick the value and then stop there. I just want one value, not all of them. And I don't care if one of them rejects. So that's kind of like different from the methods that we checked earlier, where a rejection was actually breaking Promise.all, and we had to deal with it in the Promise all Promise.race in a different manner. So in this case, Promise reject doesn't care if a promise successfully resolved quickly. It gives us this value. No need to take care or do something with this slow promise, which will resolve successfully after 500 milliseconds. This one was real fast. And it disregards also this one that rejected. Since we got one value, any of the promises resolved, this is what we get. And now let's check this section which says it rejects when all of the inputs promises reject. So it wants to pick one value. Okay, that's how it works. If none of them, none of these promises produces a value, so if all of them get rejected, then this is a failure. It says I need to pick any single value. If there are no values, I will reject, but all of them have to reject. So let me make this a little bit simpler like the previous time, the previous examples. So promise.resolve first, and then second. Let's reject this one. So pass in an array and then deal with this with then, because Promise.any returns a promise. So we have to take care of that. We will have one value, like the first one that gets fulfilled. So I hope we see first. We see the first one that resolved. Doesn't matter if this rejects. Remember, if I put Promise.all in here, it will fail. Even if one rejects, will fail. But Promise.any is like really caring only about one, and that's any of the promises that will resolve. Doesn't matter if the first or the last one. So in this case, I do get one of the values, and it will only reject if there's no value, which means if all of them reject, then there's nothing left to do. Any means a single. We need one value, right? Any of these promises, but now none of them will produce a successful value. They will all reject, so we will not get in here, which means this is an uncode rejection in this promise, and this is the case where we need to run the cuts here to see the value or values. Let's see what we get, and it's interesting to see what we get in this error. We Okay, so we get an error. You see, we don't get a rejection value, right? There's just a single error that says aggregate error. All promises were rejected, so it doesn't really give us any value. It says you wanted me to pick one value. That was your goal. I found no values, so here's just a descriptive error message that says all promises were rejected. And now in here, you would do something with this one. Now, this is a little bit, I think this is confusing because it's quite similar to race. So I highly recommend that you go and check the documentation. So have them promise.race and promise.any side by side. Run these 2, 3, 4 experiments where all of the promises reject, all of the promises resolve, some of them reject, and see how they behave differently. There's a different behavior. Promise.any has kind of like a more like exceptional, let's say, approach. So keep this alongside your MDN, because all of these provide more information about how these .any and all of these static methods get executed.